Hello there and welcome back. We need to add these two morphemes to our page of morphemes. So let me go back to that. I need to bookmark this page. We're getting a lot of these. So the two morphemes to add are hetero, which means different or not alike, and homo or homo, depending on what comes after it, means the same. So the morphemes are hetero and homo, and the meanings are different and same. Okay, back to where we left off. It's actually page 39, and we are looking at the definition of a liquid. A liquid is a state of matter that takes the shape but not the volume of its container. So the liquids, if you pour liquid water into a jar, it is going to take the shape of that jar, but it does not affect the volume. If you pour 1 liter of water into a jar, it's still 1 liter of water. The volume doesn't change, but depending on the shape of the jar, the liquid will take the shape of its container. And again, those little green balls in there are molecules. All right, a melting point is the temperature at which solid changes to gas. To liquid. Solid changes to liquid. Think about an ice cube. If you set that ice cube out when it reaches 32 degrees Fahrenheit or 0 degrees Celsius, it will start to melt. Okay, a mixture is matter containing two or more, let's just say more than one, that'll be easier. Matter containing more than one pure substance. If you want to make lemonade, you need a mixture. You have lemon juice, water, sugar, possibly ice or other flavors. That is a mixture. You put all those different substances into one container and you have a mixture. The pH scale, we have already looked at that, so I'm not going to spend a lot of time on it. It is the scale of acidity, and I'll remind you what it looks like. Remember that it ranges from 1 to 14, and here's the reminder. It's this scale right here. The pH scale is the measure of acidity in a substance. Water is neutral. Okay, a solid is a state of matter that does not take the shape or the volume of its container. So the container does not affect the solid. So I want you to think about a brick. If you put a brick in your kitchen sink, does it change the shape of the brick? No. Does it change the weight of the brick? It does not. You can put that same brick into your purse or a backpack or your mailbox or wherever you want to put it, and it will not change the shape or the volume of that solid. That is the definition of a solid. Okay, for the next three, and I'm going to go ahead and mark those. These three go together. So I'm even going to highlight that just so you get the idea here. These three terms go together. They're not morphemes, but they go together. And to help you understand this one, I want you to think about salt water. Okay, salt water is a solution. So I know I'm skipping around just a little bit, but that's okay. Let's go ahead and do this. The solution that we're going to talk about is salt water. A solution is a homogeneous mixture, so it's uniformly distributed, of two or more pure substances. And the example that I'm using is salt water. That's a mixture of salt and water. So let's jump back up here to solute. In our salt water mixture, the solute is the salt. It is the part of the solution that gets dissolved. So you put some salt in some water, the salt seems to disappear. That's the solute. If you put sugar in lemonade, that sugar will seem to disappear. That's a solute. A solvent, in our situation, would be the water. And a solvent is the part of the solution that does the dissolving. So until you add the water, the salt is just going to sit there. The solvent is the thing that actually causes the dissolving to occur. Okay, the last term is suspension. And a suspension is a heterogeneous substance, so it is not uniformly distributed. And I have misspelled that, I'm sorry. Heterogeneous substance or mixture, let's use the right word. That settles or separates on its own. I canned some tomato juice just the other day. The most beautiful red juice that I've ever seen. And I took it out, I set it on the table to cool, and the next morning when I came through, all of the red part was at the bottom, and the water from the juice was at the top, because it had separated as it cooled. That is a suspension. It separates on its own. It doesn't need help from me. Okay, that wraps up all of the terms for this module. We have one more video to do, and it is on a little diagram to help you remember some of these terms. But we are almost done with chemistry, and I will see you in the next video to wrap it up.